Welcome, everyone. We're jumping right in today. Get ready, because this explainer is going to take us on a wild journey from the absolutely microscopic all the way up to the massive scale of entire cities. We're exploring the fascinating world of digitally empowered circular economies. So if you love figuring out how the pieces of our modern world actually fit together, well, you're in exactly the right place.
Think about this for a second. What do autonomous warehouse robots, industrial waste, and a spinach plant that sends emails all have in common? I know, it totally sounds like the setup to a bizarre joke, right? But I promise you it's not. This seemingly random combination actually holds the secret to redefining how we use resources, how businesses are going to survive the future, and ultimately, how we save our planet.
Okay, let's dive into Section 1, the forces of innovation, to lay out the ground rules for this digitally empowered world. Right off the bat, we need to talk about combinatorial innovations. Look, technologies are essentially just purpose systems. They exist to get a specific job done, but they don't exist in a vacuum. Technologies combine to give birth to entirely new technologies. Think of them like digital building blocks. The more technologies we have lying around, the more blocks we have. That means the number of possible combinations absolutely explodes, and entirely new solutions get created at a radically accelerated pace. And that brings us to a crucial three-step evolutionary trajectory. Step 1 is emergence. That's when new technologies first appear on the scene. Step 2 is divergence. This is where those new technologies are applied and integrated across wildly different fields and contexts. And then Step 3, convergence. This is the magic moment where those separated technologies eventually merge together to create incredibly novel solutions. This constant looping cycle of emergence, divergence, and convergence, it fundamentally restructures global markets. It is literally the engine of modern disruption.
Moving right along to Section 2, designing circular business models. Let's look at the economic architecture these technologies are actively building.
For decades, we've operated on a linear economy. You know the drill. We take resources, we make a product, and we dispose of it in complete isolation. It's a dead end. But a circular economy fundamentally relies on cooperative networks. The secret here is that not every single business has to be a perfect closed loop all on its own. Instead, it's about connecting highly efficient linear processes sequentially. You link them together so that materials continuously circulate with minimal energy. So the crucial point is how we actually pull this off. Digital enablers, things like the Internet of Things, AI, and big data, allow companies to execute three essential steps. First, they narrow the loops, simply by using fewer resources and less energy. Second, they slow the loops, extending the life cycle of products through better maintenance and modularity. And third, they close the loops, maximizing exactly how many times a material can be cycled back through the economy. Let's zoom in on a micro-level example of this convergence in Section 3, cobotics in the warehouse. Enter cobotics, or collaborative robotics. Now, we aren't just talking about a machine repeating some blind, mindless task. Cobotics combines advanced mechanics with artificial intelligence and machine learning. By using voice, gesture, and really sophisticated facial recognition algorithms, these machines gain an incredibly advanced awareness of their environments. They aren't there to replace humans. They work dynamically alongside us, adapting to where people are moving in real time. Consider some super futuristic examples we have today, like Squid by Bionic Hive. This is an autonomous fleet of robots that uses AI and advanced mechanics to seamlessly manage inventory and dynamically optimize warehouse space. Or take EcoBots, which deploy autonomous mobile robots right into retail environments. They handle the heavy lifting, literally dealing with heavy ambient products and order deliveries. The ultimate goal of this convergence? To liberate human time and attention so we can focus on higher value, creative tasks. Okay, let's string things way down to the biological level for Section 4, spinach that sends emails. This is honestly my favorite part. I promised you we'd get back to this. It sounds like straight up science fiction, right? Can a spinach plant actually send an email? The answer is a definitive, mind-blowing yes, absolutely. Here is exactly how this works, thanks to a completely fascinating experiment out of MIT. Step 1. Scientists leveraged the biological agents of a spinach plant, which naturally draw up water from the soil. They modified the plant to detect nitroaromatics. These are compounds often found in explosives or pollution. Step 2. When these chemicals are present in the water ground, carbon nanotubes embedded in the plant's leaves emit a specific infrared signal. And Step 3.
A digital infrared camera set up nearby detects that emitted signal and automatically fires off an email to the scientists. They literally combined the biological sensing power of a plant with digital cameras to create an incredibly sensitive system for detecting soil abnormalities. How cool is that? So we've seen the micro level with biological agents and the meso level with warehouse cobots. Now let's zoom way out to the macro view in Section 5, Symbiosis. This brings us to industrial symbiosis. Simply put, this is an ecosystem that fosters innovation across entirely different industries. The goal is beautifully simple but, highly complex to actually pull off. The idea is to take the byproducts and waste from one industrial process and turn them directly into the valuable raw input for another industry. And there is a real-world blueprint for this operating today. As researchers note, Kalundborg in Denmark is a well-known example of industrial symbiosis that brings public and private partnerships to exchange streams of byproducts. This isn't just some theoretical whiteboard model. The Kalundborg network is the prime, real-world execution of a digitally empowered circular economy in action right now. Now, what's really incredible about this is the scale. 25. That is the distinct number of byproduct and waste streams that are actively, systematically exchanged back and forth across different industries within this Kalundborg network. When you look at the actual physical exchanges happening, the complexity is staggering. Wastewater from one facility is cleaned and becomes essential cooling water for another. Steam and bioethanol are fluidly passing between public utilities and private companies. Fly ash and biomass that would normally be just dumped in a landfill as useless waste, they're instead being scooped up as essential manufacturing materials by neighboring facilities. It's like a giant interconnected puzzle. So what does this all mean for us? The macroscopic benefits of this symbiosis are undeniable. We're talking about massive reductions in raw material costs, diverting tons of waste from landfills, severe drops in carbon emissions, and creating entirely new business opportunities out of pure residue. And keep in mind, none of this ecosystem-level coordination is even possible without digital tools, things like material flow analysis and life cycle assessment. They process the vast amounts of data needed to keep these resources circulating safely and efficiently. Which brings us to our conclusion, the future of circular models. We've taken quite a journey today, looking at how the very fabric of our economy is being fundamentally restructured. We've seen how biological agents like spinach, warehouse cobots, and citywide industrial ecosystems are all driven by the exact same fundamental forces. So I want to leave you with this final provocative thought to consider today. How might the continuous emergence, divergence, and convergence of technologies reshape the resource loops in your own industry? How can you use these digital building blocks to narrow, slow, or close the loops in your world? Thank you so much for joining me on this explainer, and keep looking out for those combinatorial innovations all around you.